Okay, today we're going to look at 7.4, solving polynomial equations. And we're just going to, it's basically a review of what we've done so far this chapter, except we're finding the zeros of these polynomials. So, and we've kind of talked about this. So anyway, the first example, it just says solve this equation. So we're going to do factoring, as mentioned there. So I'm going to start by factoring out just an x. So it'll be x, and then 2x squared minus 5x squared minus 7 equals 0. And then if I can factor this, I'm going to factor it some more. But once I get it to a quadratic, I could just use the quadratic formula. That would also work. But this does factor, I think, I hope. It would factor, let's see, 2x and x. That'll give us 2x squared. And it's got to be minus 7, or negative 7. So it would be negative 7, 1, or 7, negative 1, or negative 1, 7, so on. So if I put a negative 7 here, that's going to be 2 times negative 7. That's going to be negative 14. That's way too big. So maybe I'll try putting a negative 7 here, and then a plus 1 here. Now granted, oops, I wrote that wrong. Plus 1. Now negative 7 and 1 add up to negative 6, not negative 5, but that's different here. We can't use those old rules because there's a 2 in front of the x squared. So this would be negative 7x, and that would be plus 2x, which would give us negative 5x. So this is factored correctly. Alright, so then to solve it, if you recall from when we were doing quadratics, in order for this to equal 0, one of these things has to be 0. So for example, if this was 0 right here, 2x minus 7, x times 0 times whatever this is would give you 0, because when you multiply by 0, you get 0. So one of these three things has to be 0 in order to make this true. So we've got three options. One, x could be 0. The other option, 2x minus 7, could be 0. And then the other option is x plus 1 could be 0. So this is one of our answers. We don't need to do any more with that. This one we've got to do a little bit of solving, so we'd add 7 to both sides to solve this equation. We get 2x equals 7, and then divide it by 2. We get x equals 7 halves. And then this one, we'd subtract 1 from both sides. We get x equals negative 1. So our three answers are 0, 7 halves, and negative 1. Now we should talk about what this means. If we kind of sketch a graph here, I'll make an xy axis. Ooh, that's terrible. Let's start fresh. Let's use the straight lines. Okay, so there's our y, here's our x. If we sketch this graph, it should cross at 0, it should cross at negative 1, and it should cross at 3.5. And it's positive, so I know it's going to start going up, and then down through 0. It's supposed to go through 0, and then back up through 3.5. So it should look something like that. So to check it, I already plugged it in the calculator. And let's look at it. So 2x to the third, yep, that looks right. So we'll hit graph. And look at that. It crosses at negative 1, 0, and about 3.5. So it looks like we did it right. So that's good. Okay, so that's what we'll be doing today. We're just going to be solving these for 0, essentially. So that's the first example with factoring. The second example is we're going to use a graph, synthetic division, and factoring to find all the roots of this equation. So once again, to remind you, I encourage you to pause the videos and try working these out on your own and then checking after I do it, rather than just watching me do the problem. So I'm going to start by using the graph. And so I'm going to plug this equation, x to the third plus 3x squared minus 4 into y equals. X to the third plus 3x squared minus 4. Let's double check and make sure I got that right. X to the third plus 3x squared minus 4. Okay. And then I'm going to graph it. And what this is going to help me out with is it's going to tell me where it crosses the x-axis. So I need to still prove it mathematically that this is the x-intercept. It looks like it's -2 and 1. But this is going to tell me where to start using my synthetic division and stuff. So I'm going to use synthetic division next, and you could choose not to use synthetic division and just use factoring, or you could use long division, however you want to do it, but I like the synthetic division method. So I know it crosses at -2. So I'm going to use synthetic division. I'll put the -2 in the box, or I think it crosses at -2. I should rephrase that. I don't know for sure until I prove using synthetic division that it actually does cross at -2. So I'm going to put -2 in the box. I'm going to put 1, 3, 0, because there's no x term, and -4 for my coefficients. And now I'm just going to do the synthetic division algorithm. So drop down the 1. 1 times -2 is -2. 3 plus -2 is 1. -2 times 1 is still -2. 0 plus -2 is -2. And -2 times -2 is +4. And then -4 plus 4 is 0. So 0 is my remainder. 2 is my constant term, that's just the number. This is my x term, and that's my x squared. So when I divide this, I get x squared plus x minus 2. So just so we all understand, two things here that are really important. One, the remainder is 0, so that means -2 is a root of this polynomial. So I'll write the roots up here. -2 is one of them. The other thing to understand is that when we divide x to the third plus 3x squared minus 4 divided by x plus 2, we get this, x squared plus x minus 2. So it might be worth jotting down. If we did x to the third plus 3x squared minus 4 divided by x plus 2, we end up with this. And so when we divide it by a root and we have what's left over, this will now tell us what the other roots are. So now we've got a quadratic. We're really good at doing solving quadratics. You know, quadratic formula, completing the square, factoring. This one does factor pretty nicely. So I will do factoring to solve this one. You could definitely do quadratic formula if you wanted to. So this factors into x plus 2, x minus 1. And so my other roots are -2 and, x equals -2 and x equals 1. So my three roots are -2, -2, and 1. Okay, now a couple of things here. I know we need 3 roots because it's an x to the third equation. Whenever you have an x to the third, you have to have 3 answers, and we have those here. The other thing is, if we have an answer that happens twice, one, if we look at the graph, it crosses at -2, but it doesn't really cross, it's actually tangent at -2. So that's what happens when it has a root twice. The other thing is, what is this really called? So there's a term for having a root more than once. And so, since my handwriting on here is awful, I'll type it out. So the roots would be, the roots are -1, +1, and negative 2 with a multiplicity of 2. And so what that means is that one of the roots is 1, and then if it has a multiplicity of 2, that means that that root happens 2 times. So say it had a root with multiplicity of 4, then the roots would be negative 2, negative 2, negative 2, negative 2, and 1. So that would happen 4 times. So this is just a fancy way of saying the root happens more than once. Okay, now if you write like this, negative 2, and 1, that's okay, but I just want you to be aware because tomorrow's video is going to talk about stuff with multiplicity of 2, and this is what it means. Okay, so last example then for the day, it says solve this one. So once again, let's start by plugging it into our calculator. Excuse me. And I'm going to see if I can do this. I probably should try this off the video, but that's okay. I'm going to try to copy and paste this so I don't have to type it into the calculator every time. Oh, I can't paste in the calculator, so never mind. So it was x to the 4th, and then plus 7x to the 3rd, minus 51x squared, minus 207x plus 810. Okay, so here's my graph. Alright, and so the graph, it just looks like a bunch of straight up and down lines. And what happens here really is that the graph goes up, it goes way up, and then curves back down, and then goes way down, and curves back up, goes way up, curves back down, and then just keeps going down. Now, time out. I think I might have said that wrong. It starts out up, goes way down, curves up. It's going to look like a W, and I know that because it's positive x to the 4th, so it's going to look like a W, not an M. Okay. So anyway, my window's just too small, so if I adjusted my window, it would look more like a W, but it's really not that important. The important thing is, this tells us, or it looks like, it crosses at negative 6. And so to prove that it really does cross at negative 6, I'm going to use synthetic division to show that if the remainder is 0, then it really does cross at negative 6. Okay, so let's do that. So I'm going to put negative 6 in the box, and I'll write these coefficients out. So 1, 7, negative 51, negative 207, and 8. I don't need to put the plus there. 810. We'll draw our line, bring the 1 down. 1 times negative 6 is negative 6. 7 plus negative 6 is 1. 1 times negative 6 is negative 6. 51, negative 51 plus negative 6 is negative 57. Negative 6 times negative 57 would be positive 3, let's see, 60 times 5 is 300, so 342. I don't feel comfortable with that. Negative 6 times negative 57. Okay, I should trust myself more. Okay, so 342 minus 207 would be 135. And negative 6 times 135 is negative 810. And so then our remainder is 0. So that's good. That's what we're looking for. This tells me that one of the zeros is negative 6. Okay? So now we have our answer. It's going to be, this is our constant term, that's our x squared, and our x to the 3rd. So what we have left over when we divide is x to the 3rd plus x squared minus 57x plus 135 equals 0. So we'll look back at our graph and we'll see where else does it cross the x-axis. It looks like it crosses at -9, so I think I'll plug that in. And we'll use the coefficients of what's left over here. So we keep wanting to get it lower and lower until we have something that's more workable, like a quadratic. So 1, 1, negative 57, and 135. Draw our little line. Drop the 1 down. Negative 9 times 1 is negative 9. 1 plus negative 9 is negative 8. Negative 9 times negative 8 is 72. 72 minus 57 is 15. And then negative 9 times 15 is negative 135. So our remainder is 0. That means that negative 9 is also a root, which is good. And now we need to find the other two roots, and I know there's two more because it is an x to the 4th equation. So we're going to take what's left over here and find the roots from that. So this is an x squared. Oops, I want to change colors here so we're not all red. Let's go green. It's x squared minus 8x plus 15 equals 0. And we've done lots of these, and we started doing these in junior high. This one is factorable, if that's a word. This would be x, let's see, 15 is 5 and 3, and so it would be x minus 5, x minus 3. And so my other two zeros or answers are x equals 5, and then x equals 3. So I'll run up here, and so my answers are negative 6, negative 9, 5, and 3. And a couple ways to check and see if you are doing it right once you get these answers. One, obviously, is if the remainder is 0. You know you did it right. But let's say you're not totally confident in your synthetic division techniques. You could plug these in. So put negative 6 in for x, and it should equal 0. Put negative 9 in for x, it should equal 0. 5 and 3, put those in and it should equal 0. And then lastly, just double check with your graph. It looks like it crosses at 3 and at 5, so I'm feeling pretty good about myself now. Alright, so that's it for this video. Your homework will be given to you in class. It's also on my website under the homework calendar.